Okay, so let's continue with our coding exercise series. So open the leetcode.com and go to the programs tab. And in the search bar, search question number 155. So there is a question minimum stack. Come on the medium category, click on it. So let's read the question. Design a stack. So basically, it is a not a kind of a coding like a logic kind of a question, but it is a design kind of question. So design a stack that supports push, pop, top, and retrieving the minimum elements in the constant time. So we need to design a stack. We know what is stack. So stack has push operation, we have pop operation, we have top operation, and stack doesn't have the get minimum operation, but we need to implement the get minimum operation as well. So the problem is like all this operation can be implemented. Uh, we can implement like easily. Like push means like means stack is a list. So how to add any element in a list? List dot append and that particular element push done. Pop means just list dot pop also done. Top means like the last element of the list. So we can retrieve using -1, which is also very easy, right? And get a minimum. So let's suppose the list has like 10 elements, and if we want to retrieve the minimum element, then we can run a loop and on the list, and or we can sort the list and then we can retrieve the minimum element. We can do that. But the problem here is they have mentioned you must implement the solution in O of one time complexity. So this operation, push operation, is O of one because we are adding the element. Pop operation is also O of one. Top operation is also O of one. But get minimum operation is not O of one because if we have the list, so let's suppose we have the list 10, 21, -2, right? And 40. And we want to find the minimum. Then we have to loop all the elements. It's take O of n, right? So it is not O of one. So this is the problem. Right, so get minimum is the problem. So that's why like they said you can implement this, but you have to implement it over. How can you do that? So let's see like how we can do that. So let's jump to the whiteboard. Okay, we have like these operations are minimum stack. So one stack is because we have to create a stack, so we need some memory, right? So in the initial we need to initialize some memory, or we can initialize some array or a list, right? That's only then we can implement the stack, right? And okay, let's go to the whiteboard. So I just copy paste this example. So they said like first minimum stack, so some stack is given or some array is given, or you can say one memory is given. We perform the push operation and we pass the value -2. So in the array -2 is there. Okay, then again we operate the push operation and then we insert 0, then -2 0. Then we again perform the push operation, then we insert -3, then -2 0 and -3 5. Then we want the get minimum, right? So out of -3 0 -2, what is the minimum? What is the minimum? -3. So that's why like -3. So output is like minimum stack. So push is like, if you see, push operation is returning none, pop operation is returning none. So that's why like push operation is null, 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 and when we return get minimum returns -3. So green one is the output basically. So -3, and then we do pop. So pop means remove the top element. Then we say 0 -2, and pop is also returning null. Then we are getting top. So top is the top element 0. Then we are getting 0. Then we are getting rid. We have to return get minimum. So out of 0 and -2, what is the minimum? -2. All right. So how to implement? So one thing is what we can do is, so as I told you, okay, let's start. So we have to take a stack. So self dot stack. So stack is just a list, and we have to perform the, let's suppose we have to perform the push operation. So how you perform the push operation? So self dot stack dot append, and then value, whatever the value you want to perform, you want to append, which is fine. And how you are going to perform the pop operation. So self dot stack dot pop, and before popping we can check if self dot stack exists. Self dot stack exists means like it could be the stack could be empty because maybe the first operation is also pop. So if the stack is empty, then it might give error. All right. So we are checking like if self dot stack, then we are going to perform the pop operation. Also done. and now we have to retrieve the top. So how to perform the top? So top is basically like the last element of the array. So how to retrieve the last element of the array using the minus one. And we will also do if self dot stack, and we will return. So here we are not returning anything, here we are not returning anything, but we here we have to return integer. So return self dot stack of minus one. All right, so that is also implemented. Now what about this get minimum? How to get the minimum? So let's suppose we inserted 11, 10, and minus 3. Let's suppose we inserted 11, 10, minus 3. So one thing is that we can take some minimum value, minimum variable, and we can initialize with some infinite value, maybe 99999 some value. And whenever we insert 11, whenever we insert 11, and at that time we will check, okay, what is the minimum value. So we will compare, okay, minimum of current minimum value and 11. So out of 11 and 999, what is the minimum value? Minimum value is 11. Okay, fine. Then we will insert 10. Now we insert 10, then we will check, okay, what is the minimum value at that time. So we will check, okay, out of 10 and what minimum value 11. So our minimum value is 10. Okay, fine. Now we insert minus 3. Then we will check, okay, what is the minimum value? Okay, minimum value is out of 10 and minus 3. Minus 3 is the minimum value. So we can do this. But the problem here is, let's suppose we pop the element. So we pop. So we pop the element minus 3. We pop the element minus 3. But what is the minimum value? Our minimum value is minus 3, right? But we pop the minus 3. All right. So here we have the minus 3 here, right? Earlier. So we have minus 3 here. We have minus 3 here, but we have popped this. So when we have minus 3 here, then at the time minimum value is this. But when we pop this, and then let's suppose we pop this, and after that someone said, okay, perform the get minimum operation. So then minimum should be out of 10 and 11, but our minimum is minus 3. Then how we can compare? Do we need to compare minus 3 with 10, or do we need to compare minus 3 with 11? How we are going to compare? This gets complicated. We can compare, but again we need to run a loop, and run a loop means O of n time, but we have to do in O of 1. So this method doesn't going to work. Okay, what is the next method? So the next method is, we will take a one more stack. We will take a one more stack. Why we are taking a one more stack? Because here we are only maintaining, here on this side, here we are only maintaining one value, minimum value, the current value. So what we are going to do is, we are going to maintain the minimum value at every level. Okay, but at this level, what is the minimum value? At this level, what is the minimum value? At this level, what is the minimum value? So if this level gone, we know the minimum value at this level. So we know the minimum value at this level, and to retrieve the minimum value at this level, just O one operation. So that's why we will maintain the minimum value of all the levels. Okay, so let's do. So now we are inserting minus 2. So we will take one more array, minimum stack. So minus 2. So what is the minimum value? Minimum value is minus 2. So we insert into minus 2. Okay, then we insert 0. So what is the minimum value at this point? So minimum value at this point is current value, current value in the stack, and 0. So out of 0 and minus 2, what is minimum? Minus 2. So we inserted. Now we inserted minus 3. What is the minimum value? We need to insert at this level. So at this level, what is the minimum value? What is the minimum? Sorry, it should be minus 2. It should be minus 2. So minus 2 and minus 3. What is the minimum? Minus 3. So we set to minus 3. Now let's suppose we pop minus 3. So we pop minus 3. So minus 3 is going to be popped. So if top element has been popped, so we are going to remove the top element from the minimum stack as well. So we remove the top, because the whole level goes. So now we need minimum value. So minimum value will be, so here it is minus 2. I mistakenly write 0. Here it's minus 2. So minimum value will be the top of that level, because we are maintaining the minimum value at odd level. So now we don't need to worry whether minimum is 0 or minimum 2, because we know at this level we are maintaining minimum by comparing all the previous levels. All right, so my minus 2. So in this case, we need one more stack. So let's take a one more stack. Self dot minimum stack. We take, okay. So when we are pushing, when we are pushing into the stack, we are also pushing into the minimum stack as well, right? We are also pushing the minimum stack. But what value we are pushing? What value we are pushing? Because in the starting minimum stack is empty, and it could be not empty as well. So what value we are pushing? So what we are doing is, so so if self dot minimum stack. So let's suppose if there is any value. So in this case, let's suppose in this case, when we are inserting 0 and we have to fill this value, we have to fill this value. Then what we are doing is we are comparing 0 with -2. We are comparing 0 with -2 because till now -2 is the minimum value. Now we are inserting 0. So out of 0 and -2, what is the minimum value which is coming here? So if there is an element in the minimum stack, then what will be the value? Minimum of value which we are inserting, and minimum of the top of the value. So self dot min stack of -1. So basically we take the uppermost value. So uppermost value. All right. So now we have the -2 and 0, and we get the minimum value, that is the -2. Now we are going to insert that self dot min stack dot append of value. And if there is nothing in the stack, still then the value will remain same. Then we have to set the same value. That's why we use the same variable val, right? Because we are like using the same value. Because in the starting this is empty, so we have -2. So is there anything in the minimum stack? No. So what we need to insert? We just need to insert the -2. So we just need to insert the -2. Now we insert 0. We insert 0. But what is the minimum value at this level? How we are going to know? So what is the minimum value at previous level? -2. Previous level means let's get the previous level -1, and the current value which we are inserting 0. What is the minimum? Then we are inserting that. Okay. So now pop operation. So when we are popping from the minimum stack as well. So we need to do the self dot min stack dot pop. So we are popping from the minimum stack as well. Now get minimum. So now get minimum is very easy. How to return the get minimum? So we are inserting minimum, the top value from the minimum stack. So if self dot min stack. So if there is anything exist in that, then we are going to return self dot min stack and top value. Top value means -1. Let's try to run the sample test cases if it works. So sample test case has been accepted. So let's try to submit it. So our solution has been accepted. So it's a easy question. It's a design question. It's the only part could be just like, see, push is just append, pop is just pop, top is just -1. All right, and we need to implement stack, so we need stack. So only the thing is the get minimum value. Otherwise, all these three operations you can implement easily, just the minimum value. And for that minimum value, one thing is that, okay, let's take one variable, but if the pop will happen, then it will create some confusion. All right, so that's why we will take some extra memory, because they said, they did not mention that you can't take the extra memory. All right, just said the time complexity should be O1. So time complexity is my O1, but we are taking some extra memory. So why extra memory? Just to maintain the minimum at each level. All right. So that's it. That's the end of the video. Thank you.